Hi, in the last session we introduced unsupervised learning. Now in this session we'll talk about clustering tasks which comes under the unsupervised learning. So what is clustering? Clustering is the task to identify similar things with the same properties from the input dataset and group them together. This group we called cluster. Once the clustering task is completed, then you will have the data where each input point will be listed in one specific group and that data point will be the part of that big cluster. This means the output of the algorithm will have a label for each and every input data point based on their group or identified cluster, like part of cluster 1 or part of cluster 2 or part of cluster 3, etc. Have a look on the graph. Here at the input data, there are many data points, but those data sets are without label. Now, if you focus into the data, you will notice that these data points are in huge volume in some areas. This means there is something common between them. However, because the data is unlabeled, so we do not know what is common actually, but we can conclude that there is still something common. Clustering task will do the same job. It will identify the common factors in the data and then based on that, it will group those data points into some specific cluster. So now you will see, after completing the clustering task, each dataset is now belongs to some specific group, which will have some similar features or property with other data points in the same group. Now, once all the grouping is done, you can give them some generic name or ID like cluster 1, cluster 2, cluster 3, etc. And each data point will now have a label based on their group or cluster. For example, for cluster 1, the label will be the cluster 1 for all the data points inside it. Same for cluster 2, the label will be cluster 2 for all the data points inside it, and so on. Now, if you understood the concept, let's talk about few of the use cases. One most common example from the business perspective can be customer segmentation. Why this is important for business? Because every company wanted to understand their customers better so that they can serve them better. They can understand the needs and can add them into the product or services roadmap to keep them happy and making a long-term relationship. This customer segmentation can also be used to identify the right market for any specific product or services, where the customers are segregated based on the products or services acceptance and uses from some specific area, like entertainment, study, hobby, etc. And once you have that segregation, then you can target the right customer for your product or services and can improve the acceptance ratio and can grow faster. So this can be very helpful to target the focused market. There is one more big use case of clustering. This is bug or defect detection. Think a bit how you can use clustering to identify the bug or defect in any product or system. If you guess it correctly, then let me know in the comment section. Else, let me explain. So the objective is to detect the bug or defect in the newly developed feature or product or system. And what we have? We have few clusters of many different type of data, and based on that the model was generated. Now when any new feature is developed, based on its characteristics, we are expecting it to be part of some specific cluster, say cluster 2, but when we process it into the model, it moved to some different cluster, means its characteristics is less matching with the right cluster. This means there is something not okay in the future. That is why it is not behaving correctly in the test. And based on that result, we can classify it as it's a defect or not. Remember, using classification task. Same can be used in manufacturing products too. Like there is a set of good products and based on that we have a machine learning model, and when new item is manufactured, the sensors will collect the data like weight, size, measurements, etc. and based on the model it can be segregated and then later can be classified as defected or not defected. Now let's think about the little wider area. where we can use both, unsupervised learning and supervised learning, to develop an advanced machine learning system. The idea is that we can use clustering tasks on the unlabeled data, which will group the similar type of inputs based on some specific property and will give some ID like cluster 1, cluster 2, cluster 3, etc. Then we can use those cluster or can take some data points from each specific cluster and manually classify them based on their property. Like this is a cat or dog, etc. Or this is a circle or rectangle, or this is red, this is yellow, this is blue, this is green, etc. Or this is a spam or this is not a spam. This you can call semi-supervised learning. So once you do that on similar dataset or cluster, you can propagate those labels to the whole group or cluster. And boom, all the unlabeled data will be converted into the labeled data. And then that can be used for supervised learning tasks. Hence, the efforts and investment can be reduced by this approach, right? In the next session, we will talk about another important task under unsupervised machine learning, and this is dimension reduction. We will talk about its use cases with some examples, so stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.